Now for hyperbolas, we have this equation. We know we're dealing with hyperbola because we have x squared and y squared, and when they're on the same side, they have opposite signs. So if this was a plus, we'd know it's an ellipse, but since it's a minus, we know it's a hyperbola. The first thing we'd probably do is divide both sides by 2304, which happens to be 64 times 36. So if we divide this by 2304, we get x squared over 36 minus, let's see, 36 goes into that 64 times, so we have y squared over 64 equals 1. Now, to graph the hyperbola, notice a couple things. First, this one is centered at the origin, and if y equals 0, then x squared over 36 equals 1, which tells us x could be either plus or minus 6. So when y equals 0, we can actually get plus or minus 6 here. 3, 5, minus 6 to the left, and let's see, 6 to the right. So those are 2 points on the hyperbola. Let's see, x cannot be 0, because if x is 0, we'd have this negative number. We'd have negative y squared over 64 equal to 1. Since we have y squared, that's guaranteed to be positive. Divided by 64 is positive. So this negative forces this to be a negative number, and it's impossible for a negative number to be equal to a positive number, so we won't see any values. But we can still get some information from this 64. Since it's 8 squared, then we know to go up or down 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Now we can draw a little box here. That's 2 8 tall, and 2 times 8 tall, that's 16 tall, and it's 2 times 6 wide, so it's 12 wide. This box helps us figure out what this hyperbola will straighten out to. Remember, when viewed from a distance, a hyperbola straightens out and almost looks like an X. So if we extend the diagonals of this box, we get the asymptotes of our hyperbola. Our hyperbola is going to start here at this point, which is called a vertex, and move backwards. So vertex, move backwards towards the asymptote. This one, from the vertex, it'll move forward towards this asymptote, and forward and down towards the other asymptote. And this is the graph of this hyperbola. Here's a little trickier one. We need to complete the square. So we have x squared plus 4x, and we have minus y squared and minus 6y. And remember, to complete the square, the coefficient of y squared has to be 1. So I'm going to factor out this negative. Now, x squared plus 4x, sorry. So I've just sort of rearranged this. Now, in order to complete the square here, since the coefficient of x squared is 1, I can just take half of the coefficient of x and square it. Half of 4 is 2, 2 squared is 4, so I'll need to add 4 to both sides. To complete the square on this, remember I had to factor out the negative. Now I can see that I need half of 6 squared. Half of 6 is 3, 3 squared is 9, so I'm going to have to add 9. Now notice what you're doing. If you're adding 9 and it's inside these parentheses, it's going to get hit by this negative here. So adding 9 inside the parentheses is the same as subtracting 9 from this left-hand side. So I need to, if I subtract 9 from the left, I better subtract 9 from the right. Now we get this equation. These 3 factor to be x plus 2 squared, minus these 3 factor to be y plus 3 squared. 6 plus 4 is 10, 10 minus 9 is 1. Okay, so if we look at this, we know that the center is at negative 2, negative 3. And we know that we have basically a squared is 1 squared and b squared is 1 squared, so a is 1 and b is 1. So to draw the graph, we'll start at negative 2, negative 3, so 1, 2 back and 3 down. There's our center point, and we can move 1 left or right because that's what's squared underneath x, and we can move 1 up or down. So draw ourselves a little box that's 2 by 2, right? 2 times 1 by 2 times 1, and extend the diagonals of that box, and we have the asymptotes of the graph. Now let's see, if we set y to be negative 3, then x plus 2 squared has to be 1. So x plus 2 has to be plus or minus 1. So that's going to be 1 to the left or 1 to the right of the center. So there's our two vertices. So we come back, we can approach the asymptotes, and this is the graph of our hyperbola.